7.5 is all about graphing square roots and cube root functions. We got a quick warm up. Go ahead and pause the tape, graph y is equal to 4x squared, and graph y is equal to 1/4 x cubed. Nothing fancy, just a quick little sketch. Go ahead and pause it and graph them up. All right, hopefully your graph looks something like this. Parabola's a little gross, but it's a parabola. It's a little bit narrow because of the 4 in front of it. This is f of x. Then a cube root, or excuse me, a cubed is, it goes up as x approaches infinity, so does y, and the same thing with x, or with negative as x approaches negative infinity, y approaches negative infinity. But it also wants us to find the inverse of each of these functions. Remember, the inverse is the graph reflected across the line, y is equal to x. All right, so if we were to draw this like this, the inverse would be reflected across, so it would be something like this. And again, another thing that you could do is take the point and switch the x and y values. This would be the point, something like -2, 4. This would be 4, -2, sorry, down here, and then vice versa here. Now this one, reflect across the y-axis, so it would be something like this, and something like that. So those are our two graphs, and the inverse, oh, excuse me, this one is the inverse of f of x. All right, so we're going to get into the square roots. Let's use the table value to graph y is equal to square root of x. Well, can you take the, if x is -1, can you take the square root of -1? No, you can't do it. So there's no possible value for y. We could put I, but again, we can't graph it on our graph, so let's not worry about it. Root 0, 0, root 1, 1, 2, and 3. And then if you plot those points, 0, 0, 1, 1, 4, 2, and 9, 3. Now again, because we can't do negative values of x, there's nothing on this side. All right, but on the same graph, it wants us to graph 2 times root x. All right, well, we know that y is equal to root x looks like this, so we would just take each value and multiply it by 2. So 0 times 0 is still 0, but the y value of 1 would multiply it by 2 and get 2. 4, or excuse me, when x is 4, y is 2, but times 2, we get 4. 3, this would be 6. So when it's times 2, it's actually a little bit different. It goes up a little bit faster. And we got 1/2. Same thing. You take your parent graph, but we're only going to take half of each value. 0 times half of 0 is still 0, but half of 1 is a half. Half of 2 is 1. Half of 3 is 1.5. This one is much shorter. In fact, you could even say that it's narrower. That seems weird, seeing how we're using the coefficient of 1/2. Back when we were doing parabolas, it was the other way. 1/2 would make it very wide. 2 would make it very narrow. Here it's backwards. We'll talk more about that in just a minute. Let's talk about -3x. We go with the purple line, except that we're multiplying it by -3. So still 0. 1 times -3 is -3. Again, this one is very, very wide. Even though we're looking at the absolute value of -3 is 3, you would think it would be skinny. But here's what's up. We're using the inverse function. The square root of x is the inverse function of x squared. And since it's the inverse, it's kind of like Bizarro World with Superman. Those of you comic book fans would get that joke. But where what was skinny and narrow was squared, it's the complete opposite when we're talking about root x. And then here's negative root x. We'll do that one in. We haven't done green yet. Green. Take these values and just do the opposite of each one. 4 and negative 2, 9 and negative 3 would look like that. That's a very pretty graph. How about? All right, now let's talk about cube roots. Actually, before we talk about cube roots, the number in front of the radical changed how steep it was. And again, it's different than what it was with parabolas when we were doing x squared. It's the complete opposite. All right, let's talk about the parent graph of y is equal to cube root of x. The cube root of negative 8 is negative 2. Cube root of negative 1 is negative 1, 0, 1, and 2. So plot those points really quick. Oops. Negative 8, negative 2. Plot those points. And it should look like that. Now, you can see that it looks... Uh-oh. It looks a lot like my gross, nasty graph here. The inverse moves like that. Where cube root, positive functions go up very quickly, or positive numbers go up very quickly, negative numbers go down very quickly. But the inverse flips it, reflects across y is equal to x, and it makes it look like this. This is a cube root, but that's the parent graph of a cube root of x. Now, if you want to go and use your calculator, what does the cube root of x, when the minus 4 is inside, what's that going to do? Well, it's going to move it. Actually, it's going to move it to the left. No, excuse me. It's going to move it to the right. The lateral movement is still the same as what it used to be. When it's inside, it's going the opposite way of what you think. So what looks like minus 4, you would think it go left, it actually goes right. Now, if you follow this same pattern, check out, it goes up 1, right 1, down 1, right 1. It would look like this. All right, and then these other points, you could come off and follow the same pattern, but if you want to just get the gist of it like that, that's fine. X cubed, no, the plus 5 is outside the radical. What's that going to do? Move it up, down, left, or right? Well, plus 5 on the outside is going to make it move up 5. So we go up 5, looking like this. And again, you can make a quick little thing like that. As long as you got the general shape, all I'm looking for are these 3 points. Okay, and we'll talk more about that as we go. Go ahead and pause and try these two. Hopefully, you get answers that look like this. The green one moves left 2 units. The orange one went down 3 units. All right, so the general equations of square roots and cube roots. First is our vertex is going to be at the square root, or excuse me, oh my goodness. The vertex is going to be at h comma k, just like it's always been. Now remember, h is the opposite of what you think. K is what you think. But A is going to describe the orientation, whether it's for square roots, if it's like this, oh my goodness. For square roots, if it's like this or like this, and it's going to tell us about the shape. Now remember, the weird thing about this though is that shape, this one is bizarro world. It's the opposite of what we're used to. It's the opposite of what we're used to. All right, what used to be wide is now going to be skinny. What used to be skinny is now going to be wide. All right, let's do a quick example here. Unless it's the graph here. What would be the vertex here of this square root function? our square root function, our vertex would be at -2, -4. So plot that point. -2, -4, right there. Now, A, the number in front here, is 1. Now, we know what the basic shape of a square root function looks like. It looks something like that. Now, because it's 1, we're going to go up 1, right 1, and then we're going to draw a curve through it like this. We're going to draw a curve like this. All I need are these 2 points for square roots. Okay? And that's the general shape of a square root function. Let's talk about the domain. What x values are being used here? Well, look, according to the graph, none of these x values are getting used. Then the first x value that gets used is here at -2. So x is greater than or equal to -2. Look inside the square root. X can be 0 because 0 plus 2 is still 2. And we can take the square root of 2. X can even be -1. -1 plus 2 is 1. The square root of 1 is still 1. But even -2, we can do -2. -2 plus 2 is 0. We can take the square root of 0. We can't take the square root of negative. So we got to watch out for that. Y values. No Y values are being used until here at -4. -4 starts being used and then it goes up forever. So Y is greater than or equal to -4. Number 2. Another way to write the second one here, number 2 is, come on computer, oh my goodness, y equals -2 times, since this is to the 1/3 power, cube root of x minus 3 plus 4. All right, so it's cube root world. Our vertex is going to be at 3, 4. 3, 4. Now, cube root normally looks like this, right? But because of this a value, a is -2, rather than going up 2 and over 1, we got to go down 2 and right 1. It's going to be flipped. Rather than going to the right, going up, it's going to be going down like this and like this. All right, so this is our vertex. Our vertex, we're going down 2, right 1, and we're going to go up 2 and left 1. And then it's going to be a curve through like this. Looking something like that. Again, ain't got to be pretty, except for these 3 points here. I want these 3 points to work. All right, what's the domain here? The domain here is what x values are being used. All of them. What y values are being used. Well, this goes up forever, this goes down forever. It's all real numbers. Cube root, because we can take the cube root of positive, negative, anything we want, it's all real numbers for both. Number 3, let's do 3 real quick. The vertex is at 1, 0. Plot that point. Now this leading number is 1/2. Now, normally that would be wide, but because it's a square root, it's bizarro world, it's going to be narrow. So rather than going up 1 and over 2, we still got to go, we're only going to go up 1 and over 1/2. We're only going to go 1/2 a unit. And then we draw our square root like that. All right, so you're only going to go up 1, but you're only going to go over 1/2. So what's the domain here? X is greater than or equal to 1. Our range is y is greater than or equal to, what's our lowest y value? 0. All right, go ahead, give these 3 a shot. We'll talk about, or the last 4. There's also a word problem. Give these last 4 a shot. We'll talk about those in class.